The recording is going to be quiet for quite a while as I let you guys play with these. But the big request today was go over stuff that, or kinds of stuff that might be on the final. In regards to Chapter 10, I've talked a little bit about Chapter 10. It essentially takes the material that we've been doing for confidence intervals and changes the vocabulary and perspective completely without changing any of the mechanics, really, to do something called hypothesis testing, specifically null hypothesis testing. And for those of you who are going on in statistics, you'll go through that again. You'll go through this confidence interval stuff again as well. And the main difference between what we're doing and what null hypothesis testing does is it figures out, instead of figuring out like what the 95% confidence interval is, it refers everything to the tail size. So instead of a 95% confident that something is the case, you find that the p-value is 2.5, that's, or 0.025. That's the percentage chance of being outside of that. So instead of referring to everything in terms of the internal confidence level, everything's referred to as the external tail size. And it's not a bad chapter. It's not, it is certainly a useful chapter, particularly for those of you who are going to go on to that sort of stuff. Again, you'll review that stuff again. But I'm going to leave Chapter 10 up and encourage any of you guys who want to go through and do the quiz and homework for Chapter 10. I will give extra credit points for doing Chapter 10 stuff. But I think throwing Chapter 10 on top of the new vocabulary for Chapter 9 would do more harm than good right now. And it's often the case. Sometimes we have a chance to talk about Chapter 10, sometimes we don't. I'm never worried one way or the other. It's an interesting chapter to talk about, but as I said, at the end of completely changing and rearranging our vocabulary can be a little bit tough. So if you have questions about that, let me know. So the Chapters 10 quiz and homework is you're still gonna see them up there, but if you don't want to do them, don't do them. If you do them, I'll give you some extra points for it. In terms of what some Chapter 9 and or final questions might look like, I've taken these questions from old finals. So they should be very representative. And I'll give you some time to play with them. And
can you send us that paper so we can print it out?
Yeah, so I want to put that in Excel.
yeah, it's a couple of papers put together.
Oh.
So let me,
Okay.
I could build that real quick.
Okay.
Send it out. But I kind of copied and pasted it from a whole bunch of different things.
Oh, okay.
But I can organize it.
I have a question. So Chapter 10 is not going to be on the final then?
Right.
Okay. And then I had a second question. Are we going to be able to know what our grades are going to look like before the term ends?
Yes.
Okay.
Yes, I have those. My open math is a little bit behind.
Mm-hmm.
So I will try to unbehind that. I can use unbehind as a phrase, can't I? But yeah, I'll copy these down to a sheet and send them to you.
Thank you.
Is it helpful for you guys when we do problems together like this? Or are you like, oh, I gotta do this again? You know, sometimes the passive experience is more what you're looking for, but not as helpful. Where am I? Up there.
So Matt, did you print this out and send it?
Working on that. I just kind of copied and pasted it from a bunch of stuff, so I'm having to collect those all into one document.
Oh, okay.
But I'm almost done with that.
Oh, okay.
I know you, Kim and I were like, we got to see it on paper.
No.
I keep looking at it, I'm like, I'm confused. I got to see it on paper. It always works better on paper.
Okay, should be sent to you guys now.
Okay.
Thank
Let's see. Is it under messages?
Yeah, it'll say sample questions or something like that.
Oh, I see it. There it is. Okay.
There are people that we haven't seen for 6 weeks that get these emails with weird stats stuff. All right, as always, talk to each other about them. I'm gonna give you some time to play with them. Though I am gonna go grab a cup of coffee.
Huh. I'm having trouble getting it. What the heck? Okay. Do test. Okay. Okay. So on the first one, are we doing that on Excel?
I'm just doing it on Excel because I just find it a lot easier just to get just
Yeah.
certain. But you don't have to. It's just I'm choosing to do
I know
that.
that's it. I'm thinking that it's easier on Excel.
Okay, let's do it on Excel.
And when's the last time you had to deal with raw data?
Huh.
Yeah.
Like, I uh, answer for the technically first one, but it's number 2 on
Mhm.
the anyone get an answer for that, or because I have some answers, but I don't know if anyone's ready.
I'm ready.
Yeah, for the mean, I got 89.5.
Me too.
For the standard deviation, I didn't round this, so this is not rounded. 20.98765.
Uh-oh. Oh, wait. Yeah, for the mean
Standard deviation.
standard deviation. Yeah, I got that. 20.
I got
987.
the median. I got 88.
Yep.
And then I'm pretty sure we're working with T-scores here because we're talking about a mean, right?
Yeah.
Okay.
So
'Cause-
what?
Sorry, Kim.
Oh, go ahead.
For the T-score, I got 1.703.
Okay. So, T-score. Did you get that?
Sorry.
Where did you get that?
I used the T-score table in the book.
Oh. Okay. Is it asking for the?
Well, because it's asking for the confidence intervals for the population mean.
Oh, but can't we just do that off of the Excel and take the mean and add the confidence 6.7557 is what I got.
I mean, for the margin of error.
It doesn't, it just asks for the confidence interval. Doesn't it? I don't see
It asks for the confidence interval, but it's like I got the T-score just to use that so I could find. I just did it by hand. I got all the other values from Excel, but I just did all the math by hand for that.
Okay, so I just got it off of Excel because it says the confidence level you'd add in, it'd be plus, the margin of error, right, would be 6.7557.
I got that. Yeah, I got that.
Awesome. So I got that right off of Excel.
Yeah, I think, yeah. So, and then I got for the intervals, for the lower value, I got 82.7544.
Okay.
That's not rounded. Well, it is rounded, but only to 4 decimals. And then 96.2546 for the upper value.
Oh yeah, I could have done that on the calculator on the Excel.
I forget how to do it on the Excel.
Yeah, well, I mean, you could do it the way that we did it on the lab if you did the lab already.
Yeah, I have to look up the lab. I just forget.
Yeah, I know. I might.
Yeah,
I know it's easier.
I kind of like doing it by hand because it's just like it forces me to go step by step and not rush.
Okay, so you got. I think I've got my confidence interval now. So I got 82.72443.
I got 82.7544, but I'd say that's probably not too far off.
And the 96.27557.
I got 96.254, but
So it could be just rounding.
yeah.
I'm gonna, let's see. I'm gonna try to do it on Excel. Just for curiosity. So you just go equal sign. And then mean plus. Yeah, it worked.
Ooh.
Oh, how exciting. Yeah, you can just do it without a calculator.
What did you do for Excel?
So in Excel, then I just made a little box off to the side and put equal
Uh-huh.
and then mean.
How do you put mean? Just M?
No, just click on the mean, where the mean is.
On the box that you have where you use Excel to find the mean.
Oh, I didn't find mean with Excel.
2.5.
Oh, you didn't?
No.
5,
Yeah, both of mine came out. Oh, wait. Yeah, both of them came out the same on Excel as on my calculator. Oh, I'm learning so much. It's so exciting. I don't feel quite as ignorant on
9, 6. Then
computer.
You use descriptive statistics, right?
Yep.
yeah.
Input range.
So that's 132 divide 282. 32.
Output range.
And you know me, I agree more with Isabel. I like to go through and build the little, pieces. But if you're comfortable using the descriptive statistics tool to get the big chunks, then that's fine too.
Honestly, I'm not gonna lie. This might not like fly with everyone, but I don't tend to find math very fun. But I don't know if it's just because I've gotten like good at it. I
I'm muting
find
you
this
right
kind
now.
of fun.
It
What?
I'm going to mute you right now if you say that.
Really? I don't care. Whatever.
It's fun when you figure it out.
Yeah, I think that's it. I think that's what happens.
so
I'm like, I
fun
kind of
when you
like having to go, okay, here's the z-scores, here's all this, and then putting it all together.
No, Isabel, I used to be like you. I would like to do it all by hand. Because that's how I've done it. The last 2 times I've taken this 20 years apart was all by hand. Now I'm learning it on the computer.
Also, for years when I would do math, my dad would force me to do it all step by step when he would help me. So it's like, it's also ingrained in me to do
That's
that.
good dad. You have a good dad. I'm waiting to get grandchildren so I can do that. Okay, should we look at the next one?
I'm not done, but go ahead, I guess.
Oh, go ahead.
I was just getting my Excel going.
Okay, tell me if are you good? Are you on it? You're doing it on Excel?
Yeah, because I was like doing it by hand and it gave me a different, by hand, it gave me a different mean. Yeah, weird. Huh. 89.5?
Yes.
Yeah, by hand I got 87.25.
Oh, it's probably arithmetic error. One of your numbers got entered wrong.
Probably.
It doesn't say on Excel what my sum is.
If you highlight them,
What do you
it'll
mean
say
it-
the sum in the bottom
It
corner.
should be 2506.
Oh, it will add it up for you, huh?
Yep.
Yeah.
Let me go see.
20.987 for your standard D.
Yes. Yep.
And the median's 88.
Yep.
Okay. 90% confidence interval is population.
What'd you get for your margin of error?
Let's see. hang on. Let's. It's our mean plus. Where am I at? Equals mean plus or minus our confidence level, right?
What'd you get?
It's our mean minus our confidence level.
No, yeah.
Yeah.
Correct.
Equals 82.744.
I got
The lower
7244.
7244. I got 7442. 82.7442.
I got 7454. That's just rounding.
It's all what rounding stuff.
I called exact values on Excel, so it's 125,000 decimals. So, but
And then the upper is 96.255.
yep.
Are you rounding before you add
No,
or subtract?
no,
The actual numbers on there?
no.
No, I mean,
What?
do you do the addition and subtraction on Excel or on your calculator?
I did it on Excel because I have it all up right here.
So why are we having a different confidence? What's your margin of error then?
The confidence level at 90%, right,
Yeah,
is 6.7557411323.
maybe I wrote mine down wrong.
It's slightly different than what I got.
Yeah.
6.75460.
I got 6.77557.
Yeah, they're all just little differences depending on how you're entering stuff
Yeah, but why would
order
it
wise.
be different if we're using the calculator?
Same numbers.
You know what I mean? Why would it be different if you're using an Excel program?
Well, what's your
Got the-
standard error?
Huh?
What was your standard error?
Let me look.
3.96629.
Yeah, that's what I got. Did your
Standard
T-score?
error, 6.996. No, I mean, 3.966.
Yeah.
Yeah.
Oh, I used the key score from the table, so that might be why.
Oh, I just used the standard error.
Oh, wait. It's my mean times mean plus my standard error.
No, plus your confidence level.
Okay. Yeah, that's what I did.
Yeah.
Yeah, those are all fine. Just little differences in methodology.
Oh, wait, I did copy mine wrong.
Ah,
It's 6.7557.
Yeah.
Yeah. So, but yeah, it did make a difference. I just copied it. I did it once on a calculator and then I didn't double check that I got the same thing on Excel. So you're right, Camille, I think.
Okay.
So do you have 96.25574?
Yeah.
Okay. Yeah, that was me. My mistake. So maybe it's better to use Excel.
Okay, are you on the next one?
Yeah. Okay. So. Okay. Okay. Okay.
So we have this sample and we have the confidence level.
So
wait. No, we don't.
Yes.
Yeah, and we have 282. Okay.
we need to find, oh.
Yeah.
Do we need,
282.
and we have enough samples. Okay, so then do we need to find the critical value?
We need to take what is it, 132 minus, or 282 minus 132, or divided by, to get our p hat.
Oh. Well. I hate this when they're all mixed together and I have to remember which one.
I will know I did it where I divided it and I put that in for the p hat. And I got some really weird answers for the confidence intervals. I got like they weren't even in the range of 132 or anything like that. So I'm a little bit uncertain if I did that right.
They weren't in the range, huh?
Yeah, but someone else should try it that way and see, because that might have been just bad math on my part.
132 divided by 282.
Can't we just find the critical value and then this standard error? Shoot, what did I do? No, you're right. I did something like that. I can't read my own work. Let's see. Okay. We don't have the standard deviation.
0.532.
Error.
Isabella, you said your numbers were nowhere near the 132.
I am, because I got like 0.5262 for the upper value and 0.40976, unless that is right.
Well, what do those represent?
The confidence interval for the 95% confidence
Of what?
of the whole the population that said yes.
The what of the population? You're missing a big vocabulary word there.
Is
So
it
portion of
the proportion?
So is the 132 a proportion or a number of?
The 132 is just a number. It's a proportion of when you have the 132 of the, or divided by the
282.
So what numbers did you find?
So
of the P.
I was gonna do, I was gonna do the critical
Your
value.
answer is supposed to be raw values or proportions.
Oh, proportions, yeah.
So should your numbers look anything like 132?
No,
Do they look anything like 132?
no, I guess I was right. What? Yes? No?
Yes.
Okay, so I did. So, okay, then I did it again and I think I got it right. Okay.
The interpretation of that, noticing that that 132 is a very different type of value than the 50, whatever it is, 52% of the 40%.
Mm-hmm.
Being comfortable with what you're looking at there is important.
Okay.
That make sense?
That makes sense. And then I did it again and I got the values. I just was like, wait, that seems weird. So.
If you wanted a high and low for the number of, you could multiply the 282 by the 41% and the 53% and get those values.
Okay. Yeah.
If
So-
one was in that mood.
Matt, can we find the standard error there by taking the square root of 0.468 as your P?
Yep.
Yes?
Yep.
Okay.
oh, never mind.
And then their Q is -1 times 0.5319 divided by 282. So
All right, I'm gonna go grab something. Give you guys a chance to work in peace.
Okay, so
okay, so I got standard error is 0.0297.
me too.
Okay, now
So now our equation is where am I at?
so
Shoot. Did I just do that part wrong?
oh, then we have to take it times the critical value, right?
Yeah. Well, plus or minus. It's our wait, what?
No. We
Oh
change-
yeah. I'm
and
past
that's our margin of error, right? So we take standard error times
no.
the critical value. And then
What? Standard error.
Isn't it- okay. So so the mean is p hat is the 0.468.
Yes.
Isn't it 0.468 plus or minus
Yeah.
the critical
Yeah.
value times the standard error?
Yeah.
So to get the critical value,
Um,
we do inverse norm.
Yep.
Um,
And I got 1.65.
for 98, so 95. Oh, we can just use that chart thing, right?
Yeah, or use inverse norm.
Okay,
Yep.
and that's your plus or minus 1.96, right?
Yeah.
yeah.
Times our standard error.
Wait,
That's what I think. I
I'm so dumb.
don't trust me.
This is wrong. I'm a dingus. I
So I got a margin of error of 0.0582.
Yep, that's right.
But
You got
I felt wrong. It was proportion.
then our
your margin of error is what?
I got 0.058.
It was a dumb move on my.
Did I forget a step again?
Oh, Camille, what'd you say?
Did I forget a step again?
Where for what?
Well, because I got my lower bound, I got 0.468 minus 1.65 times 0.029.
What did that equal for the lower value?
Yeah, that equals 0.42015.
I got 0.4099976, but that again might just be a rounding thing.
And then the upper value is 0.5185.
I got 0.5262, but again, I think that might just be a rounding thing.
Yeah, I got what you got, Isabella. Camille, what z-score did you use in there?
I
I
used
used
1.96.
What'd you use?
1.96.
Yeah.
I used 1.65.
Okay, that's probably why.
I
Yeah.
put it in inverse norm.
Oh, what'd you put into inverse norm? Because if
The
it,
area of 0.95.
No, it's 0.025.
yeah, you put in like the tail, like the remaining tail. What if
Right.
you put the distribution? You get the other part of the tail, and that's what you put in inverse norm.
Oh,
Is the-
hella. Oh, yeah.
So let's see. Okay, so what did you guys get as your confidence levels?
I got 0.5262 for the upper level.
Yeah.
And 0.40976, which could be rounded.
That's what I got.
Whatever you-
Yep. That's what I got.
I don't know why I thought that was wrong. I don't know why. Because that was what I was saying before, is I thought the weird answers were actually the right answers.
Yeah.
Oh, because we're looking for the z-score, not the t-score.
Yep.
Mother trucker.
Language.
Camille, the way I
Yeah.
like to remember it is like means, t-scores, z-scores are not.
Well, I'm
Not
looking at the
means.
equation and I'm filling in the equation. I'm looking at it. It says z-score. It says that's what you are asking for, but I'm trying to give it a t-score.
That's
Good.
okay.
I even looked at the paper and I'm like, that's not what it is. That's not right. I'm going to use inverse norm because that's right, because I'm putting in the wrong number. And it says 1.96.
Well, the inverse norm would work as long as you used the
I'm
cumulative
like,
value,
right. Yeah.
the 0.975 or the 0.025. You just gotta remember to use that half value, that 1 minus n divided by 2 value.
Okay, let's try this again. Okay. 0.52455.
Yep.
Okay.
Or 0.52, but
Right. Stupid. I mean, it's comforting to know that I mostly know the process. Okay. We're rounding to 3, right?
I think he said 4, but honestly, I kind of just kind of round to 4, and then
Yeah.
if he then rounds to like a whole number, then I'll just kind of follow that. Or if he rounds to 2, I'll just follow that.
Well,
Yeah. 262.
Anyone have a response to number 4 or the first number 4?
Well, to me, it sounds like it's not correct because isn't he supposed to say that he has a 95% certainty that
Yeah.
the donations lie between
It's
us, not
yeah,
95% of the donations lie between us.
yeah, because confidence levels or a confidence is not a probability that something will happen. It's like, oh, you have a 95% chance of this happening. It's
Right.
I'm 95% confident that this will be the range that is.
That's what I'm thinking.
We're on the same page.
What do you think, Matt?
That it will be the range of what?
The range of
The range
the range
Of
of
the average
donations. for the
donations?
data.
No,
Range of donations.
that's the same statement as they have there.
The confidence level represents the range of means, not individual donations.
Right.
Yeah. Thank you, Andrew.
Yes.
So how would you change that statement then, Andrew, to reflect that?
Oh.
Would you just change it to 95% of our average donations, or between that and that? Or would you do something more dramatic?
Can't we just say we have a 95% confidence that our average donations lie between 132.7 and $147.13?
I have a very slight problem with that statement, but
Okay, what's wrong?
very close.
Kim, can you repeat what you said, please?
Okay, I said we have a 95% confidence that our average donations lie between $132.57 and $147.13. but it's not quite right.
Only if I'm being
So-
extremely picky,
Yeah,
which I am.
that's okay.
Also, Isabel, you said very directly that the 95% wasn't a probability. It is still a probability.
Oh,
It's just the difference of the probability of, what is it the probability of? You're correct in saying it's not the probability of where our donations will be. It's the probability of something else.
okay. Thank you for that.
So that we're not doing math, we're just trying to express what this means.
Which is math. We're not doing arithmetic or algebra.
Right. Okay. In their next press release, the manager writes that no, it's not correct.
So yeah, Kim, my only problem with your statement was really the S in donations. 95% that our average donations are between that and that. It's really either the average donation is between that and that, or the average of our donations is between that and that. Average donations adds a twist that's just not quite. That's, again, me being very, very picky.
Okay.
But you're being very formal of we have a 95% confidence interval that, as opposed to trying to put it a little bit more in the language that they're using. If we wanted to say more of it, if we wanted to say it more probabilistically as a probability, there's a 95% chance that the average of the donations is between 132 and 147. It still is a probability. It's just a probability of where the true average is. It's a 95% probability that the true average is between 132 and 147.
Okay, so is this right then? There is a 95% chance that the average mean is between 132.57 and 147.13. Is that the right way to say that?
Yes. You can hear it in my voice a little bit, right? Because that's why you like that. Yes, you said the average mean, and that's a little bit redundant. I would say either the average and
Or the donation? I put donation?
Donations is fine. You just said
Okay.
the average mean, and that's a little bit redundant. I'd either say the mean, the average. If you wanted to say the mean average, that's mean as an adjective. Average mean sounds a little bit
Weird.
weird because then you're averaging up your means.
Okay, so the average
But-
donation or the
Yep.
okay.
Average donation, I think, is fine.
Okay. It sounds good, better.
Or the mean donation.
Or the mean donations. Oh, okay.
But yeah, Kim, yours was essentially correct. I'm good. It was just, I like being especially picky with you.
Okay.
Okay. Now we're looking for sample size.
Number 6. Oh wait, number 4. Wait, what? What the hell?
Number 4.
Number
Second 4.
Number 4 too.
Yeah, 4 2. Okay. Okay. So is that where we solve for n?
Yes.
Yeah. Yeah.
Okay.
So we're doing algebra.
So we want
What sample size? I'm not good at these ones. I like know that that's what we're supposed to do, but I get stuck. So
about
There's also an equation in the book that's when you don't have a sample, a specific sample size.
okay, what's that?
right, it's
Well, if you have a sample size or a probability, or you have a p hat, it would be n equals p fat, parenthesis 1 minus p fat times z score divided by the standard, margin of error squared. And then if you don't have
What's the square
don't have a
root of n?
if you don't have a p fat, it would be a p hat, it would be 0.25 times z squared divided by the margin of error squared.
I was thinking of using the one that's
I think it's one that's like you times it by s.
huh?
I know that with t-scores, you times it by s. You have n equals z times s over e squared over e squared. Oh, you square everything.
Isn't it like the last one on 9.2?
hang on. I'm trying to look where you're
Number
talking about.
16 on 9.2?
It's for t-scores, it's on page 442 of the book.
Of course, my book's different.
Yeah, it says average salary, so that's indicating to me that we have a mean. So anyone can correct me on that.
What sample size would you need to order there? Standard
Why
deviation.
would it be way back there?
Yeah, I feel like I agree with you, Kim.
Yeah, I'm thinking that it's,
I feel like I agree with that.
look at the number 16 on our 9.2 homework. Isn't it like that?
Yeah.
Mm-hmm. Yeah, sounds about right.
So we're up in 9.2.
Yeah.
So I thought it was the margin of error equals the, let's see, where did I get to? P hat, I think, times 1 minus p hat divided by the square root of n. Why am I thinking that? Okay, what is
I think Matt mentioned doing it that way in class.
yeah,
I don't remember him using.
nine-
I don't remember him using the equation in the book, even though I found the equation in the book a lot easier.
217 is 90. Is that 217 is that 90 inverse norm for 97, which is 0.15? Let's see.
What are you looking for? 97. You're doing the. So our
Rory or Levi or Bobby, for Camille, do you guys have any help for them?
Yeah, well, I'd say we're not really looking for p hat here. We're looking for the mean, but we just
Yeah.
for range, we don't have a mean and we don't have a standard deviation. So I was thinking maybe we could use that like rule of 6 where you divide the range by 6 to try to get that standard deviation, but that's the best I could think of.
I was gonna say for the margin of error, you could use the 1,000. I remembered there was a question in 9.2
Right.
where you
That's
had
what I thought.
you had the extra value at the very end that said no more than or something else, and you could have put that into the for the E. But when I did that, I got like the point, like a decimal, and then it had like the -7, which would have like 7 zeros, 6 zeros in front of it. I'm like, that doesn't seem right at all.
Let's see.
I think Andrew's main point, if you don't mind me interjecting, Andrew, was you guys keep talking about p hat. P hat says you're in a probability question, in a proportion question.
But we're not.
Can we?
Then don't mention p hats.
So can
Anything
we
with a p hat in it
Z-score?
is proportion problem.
Can we do the Z-score for 97%?
It's 90%.
Oh, wait, this is 90%. So can we use
1 minus 90.
the 1.64
Yeah.
margin of error, 1.64 times, let's see, times,
Yeah, the problem though is we don't know the standard deviation. So Matt, would it be appropriate in this one
should we do the mean?
to do
Well,
what
we are
we
looking
did in
for the
class
mean.
a couple days ago by dividing that range by 6 because we know that almost all is in those 6 chunks.
If you can talk them into it, yes.
What are we
Like,
dividing by 6?
Wait.
Define
What do we divide by 6, Andrew? Sorry, Camille.
So the range, the difference of the 52,500 minus 18,500, we get the range of actual values, and we know that we have a mean in the middle if it's normally distributed, and we have 3 standard deviations out in either direction will give us almost all of the data. So if we divide that range by 6, we'll have we'll be dividing almost all the data by 6, and so we can get the standard deviation.
So with the range, do we subtract it first and then divide by 6, or I'm not remembering.
3,500 minus the 18,500 and then divide by 6 to get a rough estimate of the standard deviation.
Okay, divide 6. Okay, so I'm getting 5,666.6667.
Yeah, that's what I got.
Okay. So let me write that down.
You got what?
I got after dividing 6.
Yeah.
I got 5,666.66667.
So did I.
Divide 6.
And
And then
so what is that number? That's our
So since we don't know the standard deviation, that's just kind of like our rough estimate of
a
it.
rough estimate
And
of
then-
what it would be.
And then we would multiply that by our critical value to get the margin of error that we can put in for E. So I'm getting confused now. Oh, that's standard error. That's not standard deviation. What am I doing?
Yeah, so to find the margin of error, we multiply by the z-score times that standard deviation divided by the square root of n. So I
There
think
we go.
the 1.65 times, the 500 or 5,666 divided by square root of n and set that equal to 1,000, since we know that it has to be less than or equal to 1,000.
Alrighty. Okay. So here we have to do the algebra. Okay.
Now you could still put it into that formula if you wanted to.
But you
you know, I
can't
like
use
the algebra.
your calculator.
But maybe the algebra is a little more fun.
I think so.
Okay, so let's see. I was 1.64. See, that's what I had. Well, that's what I was. Okay, that's where you get that. Okay,
Yeah, now I'm stuck again.
okay.
Divide both sides by n.
You divide both sides by n, or you multiply both sides by n?
Multiply by n. So if you multiply that by n, and oh, I'm not good at this. N cancels out the n.
Right. Okay, that totally makes sense. Okay, so I was right. It's like that problem number 16, but they give us the standard deviation in number 16, and we have to come up with it.
Oh,
That's what it is.
yeah, I don't. $1,000 equals. Oh, my shit's all messed up. I don't. Wait. How do I do it not the algebra way? Because I get so confused with what you're doing there, writing that down like that.
How do you do what?
I get it. I get confused on what to do.
On the algebra?
Yeah, I have 1,000 equals 1.64 times
Okay,
556 divided by squared n.
okay, Camille, the
Yeah.
easiest thing to do is put a 1 under the 1,000, which makes a ratio, and then multiply diagonally. You remember doing that? Doing the product?
I just don't.
So you have 1,000 times the square root of n equals 1.64 times. And then you just divide, you just change places with the 1,000 and the square root of n.
Well, let's talk through it. Camille.
I don't understand.
So you've got the 1,000 equals the 1.64 times the 5,666.67 divided by the square root of n, right?
Yep.
What's the first thing you want to do?
Huh?
To
What's
solve
what?
for that n, what's the first thing? What's the first thing you want to do to try to solve for that n? What's the first thing you want to move?
I don't know.
If you had to pick something.
I don't know. Unsquare root it or something?
You could square it. I would tend to isolate that square root before you do that. But you could square both sides at any point. If you squared both sides right now, you'd be squaring the 1,000, you'd be squaring the 1.64, you'd be squaring the 5,666. You'd be squaring a lot of big things. I'd probably divide this off first. So I'm going to divide both sides by that 1.64, divide by that 1.64. Now, if you want to actually do that, like take the 1,000, divide by the 1.64, and tell me what you get.
But Matt, don't you think just doing like cross products is the easiest?
Property of proportions, you could, but I don't think that's with that square root and with the multiple terms on the right side, I think that's causing more confusion than
Trouble.
less.
And,
Okay.
and Andrew, what did you get for the N?
Sorry, what was that?
Did you get
Andrew, what'd you get for the N?
At the end?
Yeah, N for the end. Yeah.
Oh yeah, I was just waiting to do it all together, but yeah, I haven't actually put it in the calculator yet.
I got 86.
So, Camille, when you took the 1,000 divided by the 1.64, what'd you get?
609.756.
That seems reasonable. And that equals the 5666.67 divided by the square root of n.
Inside, I'm so done. I'm dead.
Fair so far?
Okay. Okay.
And then the tricky part is, what do you do with that square root of n down there? How are you going to get that square root of n to not be in that denominator?
I multiply it out.
Good. So we multiply both sides by that square root of n. Removes it from that denominator, which is good. That was an annoying place for it to be. And we've got that square root of n times the 609.7 equals the 5666.67. Okay, still trying to isolate that n. What do you want to get away from that n now?
The square root.
You could get rid of the square root right now if you wanted to. The
Oh,
risk
or-
there is that it's easy to forget to square the 600 that way.
Okay. So we want to get rid of the end number because it's not in parentheses. The 56667.
Yeah, the 6, is it 66 or 6097? Is your number? I think it was 60. So if we divide both sides by that 609.7,
Oh.
then we can isolate that square root of n and get a smaller number on that other side.
9.29.
Camille, that's where I'd square both sides.
Nine two nine. Okay, so
And that's what, 86-ish?
Yeah, I got 86.3820, but I'm rounding.
86.365.
Depending on what you're rounding. Now, your book does have a formula for that. You could just plug it directly into, this is essentially what we did when we divided everything over and moved it and squared it.
Oh, I think this is what I was thinking of, but I did it for the z-score, not the z-score one, but for like what would be for not means.
For proportions.
Sorry.
Yeah, that's what you were talking about with proportions. And you were quite right. If we don't use proportion, if we don't know the proportion, you use a proportion of 1/2, and the 1/2 times 1/2 is what makes that 0.25 in the formula.
Yeah,
So-
I should have known. This is the other one I was thinking of with z-score times this times the standard deviation divided by the margin of error was where you squared. That's what I should have said that one.
Now, I'm of course glad you didn't, because that got us a chance to talk about solving, but we do have a tool that avoids that. That's probably one of the, solving for those ends is probably one of the harder solvings, because we're solving for something in a denominator. It's often in a radical. So those can be a little bit,
So I take the sample times the critical value divided by the margin of error.
the standard deviation times the critical value divided by the margin of error squared. I am always one for do the algebra instead of memorizing extra formulas, but there is a place for them. So, you know, you don't want to be too rigid about that.
5, 6, 6, 6 times 1, 6, 4 divided by 1,000 squared.
Yep.
Not the trucker.
And it was 86 point something because our standard, our n has to be a whole number. It should be rounded up to 87. And if you were doing this, because we have to use that z-score instead of the t-score, we know that could be a little bit off, so we tend to round up even more. So I would probably say somewhere between 90 and 100. But technical from the formula, 87. Generally, these questions are essentially asking what is the minimum sample size necessary to make it happen. Your book talks a little bit about that whole range divided by 6 thing, but not too much. I tend to emphasize it a little bit more just because it is one of those things that happens a fair amount in practical applications. So for those of you who go out into the field to do things, it's surprisingly common to have to do that, particularly for preliminary samples. So 6, 9, and 11 we'll have to talk about tomorrow. Think about or look for, find other questions that you guys would like to look at tomorrow. And come up with what you think might be helpful for you guys tomorrow. And let me know.
And so I just want to double check that at this point, unless we want to do chapters 10 for extra credit and we've completed our lab and our quiz, we just have our test left that we need to study for, correct?
Yes.
Okay. Thank you for putting this together.
Oh,
Yeah.
working
Hey.
on fun problems is always a good time for me.
Oh my God, so fun.
Yeah, this was really helpful.
So fun.
Okay.
It's
But yeah, do finish up 6, 9, and 11. I gotta log off so I can get the recording to start processing. If you guys want to get back on and finish these up together, great. Anything I can do for you guys before I head out?
oh,
I did have a question for you, Matt, but it was just kind of something I needed to ask you.
You want to send me a message, or do you want to?
Yeah, I can do that.
Okay.
It's just about the final exam because I already sent you about it earlier, just about like opening it a bit earlier because I have to get it done.
Yeah, actually, I was going to ask if anybody wants to do it Wednesday instead of Thursday. That's fine. If anybody wants to
Yeah,
even
that's
do
what
it
I want to
Tuesday,
do.
that's fine.
Um,
Okay, I'll open it. I will set it to formally open Wednesday.
Perfect. Thank you.
Okay.
Okay.
Anything else? Okay. Let's see.
Kim, are you good? Do you just want to wait, do more tomorrow? What do you want to do? Do you want to do anything?
Did you finish all of 9.2?
Yeah, we could go over it.
Yeah, I just didn't do, let's see.
Yeah.
I'm behind on. I didn't finish. I've done part of 9.2.
Yeah, do you want to log back in and I'll do it with you?
Okay,
Okay.
try that. Okay.